30 sondes today, they're like TDR probably by the first point. First point's going to be
thousands of miles away from where it will move on shore along the U.S. West Coast. Scientists, pilots, and technicians gather in Hawaii to prepare for a mission where they'll fly into what's known as an atmospheric river.
An atmospheric river is essentially a river in the sky. And if you calculate how much water vapor is moving in an atmospheric river, an average one is transporting 25 Mississippi rivers worth of water. They make or break whether or not we have enough water or too much. They are vital to our entire global water cycle and are key to producing precipitation and flooding and ultimately beneficial water supply.
The crew flies on the NOAA Gulfstream IV jet, nicknamed Gonzo because of the large radome jutting out from the nose of the aircraft.
The NOAA G4 is a really great asset for the airborne reconnaissance missions because of how high up it can fly. So it reaches about 45,000 feet, and that really allows us to get a full profile of the atmospheric characteristics that we're concerned about in these missions. It can also fly pretty far. So the atmospheric river flights that we usually conduct last about 8 hours. They're usually in length about 3,200 nautical miles.
The NOAA G4 aircraft is a vital asset for AR recon. It's really one of the foundational pieces. It flies relatively fast and can cover a large area over the ocean quickly enough that when we collect the data, it can go into the weather models in a timely way and help make the forecast better.
Gonzo is equipped with a variety of high-tech equipment to help study and forecast these important weather events.
The type of tools that we're using in atmospheric river reconnaissance are really primarily a dropsonde. It's a sensor that measures temperature, moisture, winds, and pressure. So it's giving us a really high-resolution vertical profile of the atmosphere.
And it actually drops about 40,000 feet from the aircraft. Within the 6-hour period that we sample with the dropsondes, we can make maybe 25 or 30 of these samples, and they really provide us almost like an MRI of the AR. And then the data are quality controlled by the crews on board. Then it's transmitted via satellite communication to a big bucket of weather data that the whole world's weather models use to help make the next forecast.
We also use the tail Doppler radar, and then we are also using other observations, getting profiles of temperature and moisture at tangents to the aircraft, so complementing that vertical dropsonde profile.
The aircraft helps fill a void in tracking atmospheric rivers where other technology falls short.
The atmospheric river is one of these phenomena that the satellites don't really capture very well. And it's up in the air, so it's above the ocean surface, so it's not necessarily captured that well by the ocean data. It's this gap in the observing system. To fill that gap, we've tapped into the nation's capacity for weather reconnaissance using aircraft. And we use those aircraft, including the NOAA G4 and soon to be the G550, to go out over the ocean and measure the storms in great detail. Like with surgical precision, we sample the temperature, pressure, moisture, wind. We know exactly where that AR is. We know its structure. We know the environment around it. And the farther west we can go, including out of Hawaii, the more lead time we get to see these ARs coming. That information is priceless for weather prediction.
The data the crew gathers while flying on NOAA's G4 will help to anticipate the effects of one of the biggest factors influencing the West Coast water supply.
The observations collected by the Gulfstream and others during the atmospheric river reconnaissance campaigns have been shown to have really important impacts for precipitation forecasts on the U.S. West Coast. And that includes the forecast of just how much overall precipitation will accumulate, where will it accumulate, and how long will that precipitation accumulation period last. Those are all really, really important things for water managers and emergency managers as well.
And these missions would not be possible without an array of experts supporting them.
These flights, which are so vital to air recon and to water management, they're conducted by professionals, pilots, engineers, staff on board the plane and on the ground. And that team makes sure that the flights are done safely and that the equipment's working and that the data's flowing and that the aircraft can go where it needs to go. Those crews are vital to our success.